Hello and welcome to this episode of Math with Martinez. In this episode, in our unit on systems of linear equations and inequalities, we are going to be discussing matrices with the goal of solving our systems using these matrices. So let's go ahead and get started. Before we can begin solving our systems, we are going to need to discuss a couple of big topic ideas related to matrices. The first is that of an identity matrix. The identity matrix is denoted with this notation. You're going to see whenever we're talking about the identity matrix, it's going to be a capital I. It's going to be a capital I to represent that matrix. And it is a square matrix then when multiplied by another matrix equals that same matrix. It's kind of like the identity matrix is like, it is like multiplying by 1. It's like multiplying by 1, but the matrix version. So that's a little note that you might want to keep in mind. It's like multiplying by 1, but when you're working with matrices. So on to our next bullet point. It says if A is an n by n, meaning same number of rows and columns, matrix, and I is also that same dimension, right? These are our dimensions. Then what we can say is that A, whatever matrix A is, times the identity matrix is going to give us A, the same original matrix right back. Or if we change the order in which we multiply the identity matrix first and then matrix A, the result will still be matrix A. It's like multiplying matrix A by 1. You're just going to get that same exact matrix A back out as the result of that multiplication. Okay, so we've been talking about an identity matrix, but we don't really know exactly what they look like. Let's look at bullet point number 3 here. An identity matrix contains ones along the main diagonal and zeros for all the remaining elements. So a 2 by 2 identity matrix will look like this. You're going to have 1, 0, 0, 1. That is an identity matrix that has the dimensions 2 by 2. And what is meant by ones along that main diagonal, right here along our main diagonal, you have ones, and in either of the other positions, you have zeros. Now, if we had a 3 by 3 identity matrix, a little bit bigger matrix, it's going to look like 1, 0, 0, 0, 1, 0, 0, 0, 1. And again, we can see here along that main diagonal, the elements are 1 and all the other elements are zeros. So with that in mind, I want to now discuss another special type of matrix, and that is the inverse matrix. 2 matrices that are n by n in dimension are inverses of each other if and only if we have this, that their product in both orders, meaning whichever way you multiply A and then B or B and then A, But either way, we want it to be the identity matrix when we multiply. So if you multiply A and B or B times A, then their product is going to be that identity matrix. So if matrix A has an inverse and it's denoted as B, then A times B will equal I, where I is our identity matrix, and B times A will equal I as well. So I want to demonstrate that here with this first example. Let's determine whether the pair of these matrices are inverses. You're going to need to go ahead and pause this video and input matrix A in your calculator into that matrix area that you have, that editing capability, and input matrix B as well. Go ahead and pause your video and do that now. All right, now on the computing screen, let's go ahead and take matrix A times matrix B on your calculator and see what is the result when you multiply those two matrices together. What is the resulting when you multiply A matrix and B matrix together? Well, when you do that, the result, their product is 1, 0, 0, 1. And we know that that is a very special kind of result. This is the identity that was the identity matrix. Let's also check that it is true in the other order where you take B first and then multiply it by A. It must be true both ways. Will you go ahead and multiply B times A now and see what that result is? Again, the result is 1, 0, 0, 1. We have once again the identity matrix for both. And so therefore we can say yes, they are inverses. All right. Let's take a look at this next one too. What is the result? Let's determine if these are going to be matrices, yes, that are inverses, or no, that are not inverses. Once again, to be able to determine this, we're going to need to take matrix R and S and multiply them. If they are inverses, based on our definition of inverse matrices, if they're inverses, either way we multiply, the result is going to be the identity matrix. So go ahead and in your calculator, now go ahead and put in matrix R and S. Put in that matrix R and S and see what is the result. You may have to rename R and S. You could put them in position A and B since our calculators don't go all the way to listing R or S. So go ahead and put those in your calculator, multiply, and see what is the result of R times S. All right, well, when you multiply those, the resulting matrix is 96, negative 31, negative 56, and 18. So that is a hard no. They are not inverses because their product was not the identity matrix. So ladies and gentlemen, I introduced those because we are going to need to have an idea of these identity matrices and inverse matrices as we look at solving systems using matrices. To solve a system that has 3 variables, yes, check it out. Look at what we've got in our system down here below. We have x, y, and z. We've got 3 variables. The first thing that we're going to want to do is to represent our system using matrices, such that the coefficient matrix A is going to be multiplied times the variable matrix x, like you see here on the side, and then that's going to equal our constants. So I want to go ahead and show you all that with this first matrix. Check this out. We're going to grab our little highlighter here, and I'm going to highlight these very strategically. Notice here that I have the coefficients of x, the coefficients of y, the coefficients of z, and then last of all, I have my constants. So when we set up our matrices here, we are going to begin with our A matrix. We're going to begin with that A matrix, where A represents all of the coefficients. So we are going to put our coefficients in order like we have them, beginning with our first column as our coefficients of x, our second column as our coefficients of y, and then our third column as our coefficients of z. So that would mean I would have in my first column 2, 5, and 3. In my second column of my matrix, -6. Now the coefficient of y here is, y'all love it, my best joke, right? It is the almighty 1. And similarly down below. And then we have in our final column the coefficients of z, which are going to be 9, 2, and -8. We're going to multiply that with our x matrix, which is our 3 different variables. What are our 3 different variables? X, y, and z. Lastly, that is going to equal, well, let's check it. What dimensions do we have here? This is a 3 by 3 matrix. This is a 3 by 1 matrix. Can we multiply these 2 matrices together? Is that defined? We sure can. We can multiply them together because these match. So that makes me happy. If they match, then we can multiply. And the result is going to be those leftover numbers, those numbers on the outside, the 3. It's going to be a 3 by 1 matrix. So 3 rows, 1 column. That is our coefficients. And those coefficients are what we highlighted. It is what each of those equations is equal to. The first, -8, 10, and -28. All right, so we have set this up. We have carried out step number 1. Now we need to enter the A matrix and our C matrix onto our graphing calculator in both of those respective locations. After we've done that, we're going to want to left multiply. We're going to want to take and left multiply matrix A by matrix and matrix C by A inverse to solve for our matrix X. Because here's what happens, ladies and gentlemen. Focus in right up here with me. When we multiply by the inverse of the inverse of A, those are opposite operations, and the result, when you have the inverse, when you multiply a matrix and its inverse, what does it always give you? Whenever you multiply a matrix and its inverse, it's going to give you the identity matrix. So if I multiply matrix A by its inverse, the result is the identity matrix. But whatever I do on one side, you know how that goes. We must do to the other. So I'm going to multiply matrix A inverse and matrix C. That is going to allow me to solve this equation. It's essentially like saying, if I would have had A times X equals C, and I'm trying to solve for X, well, I would have to divide. But we are not able to divide matrices. I cannot, that is not a performed operation. So what I'm going to do is multiply by the inverse. And whatever I do on one side, I do in the same way on the other. So if I'm multiplying it on the left, right? See, I'm multiplying on the left side. Then I must multiply C also on that left side. That gives me the identity matrix times X is going to be equal to A inverse times C. Well, X being my variables times my identity matrix, anything times the identity matrix is just itself. So all we need to do in our graphing calculators is take what is A inverse times C. So you would just need to type into your calculator. Let me make this a little bit neater here so that it'll look like it does on your graphing calculator. You're going to take matrix A inverse times matrix C. All right, and when you take that product in your calculator, you will have that X is equal to -1, 7, 4. So now we're on to our final step here. Now that we've done the left multiplying to solve for X, now we need to interpret matrix X. What this means is, like you can see here, -1 is our X. -1 is our X value. So if you were to list these as coordinates X, Y, Z, the point of intersection for these three equations would be where X is -1, where Y is 7, and where Z is 4. That is the point where those three equations in this three-dimensional plane are going to cross. This is the value where each of them is true. So that is interpreting our matrix in order to solve our system of equations. Ladies and gentlemen, and that is all for our video today. If you had any questions, will you please take a moment to share those now? And until next time, stay fired up.